1, 2. Okay, thank you. Let's wait a couple of minutes because it's still people outside. Okay, good morning. Good morning, everybody. My name is Heikki Pitkänen. I'm from the Finnish Environment Institute, and I'm chairing this morning session, which is called Techniques and Physics. And our first speaker is Ivan Kuprianov, and his topic is the Hazelift Project, Assessment of the Transboundary Issue of Chemical Pollution in the Eastern Gulf of Finland. Please, Ivan, the floor is yours.
Thank you. Is it working? Seems not. Microphone is not working. Oh, now it's working. Yeah. Good morning, everyone. So let me speak from my heart, so I will start. I'm a corresponding author of this presentation and coordinator of the project funded by Cross-Border Cooperation Program. Much more people have been contributed to the project. Some of them will be mentioned in the publication I will show, or some will be just on the pictures. So the project got funded by the program, and it will be slightly extended. Here is duration 35 months. Actually, it will be 38 months due to COVID restrictions we have experienced during the project. But the budget was quite good of this project, quite extensive. We could do a lot of different interesting activities. And background, I will start from background. So environmental problems related to effects of hazardous substances are very important in the Eastern Gulf of Finland. So they are developed HELCOM core indicators like trace metals, pH, PCBs, organotines, phenols, pharmaceuticals that actually treat the area environment through accumulation of various environmental matrices and finally altering biological function of aquatic organisms. So the partners in this project was Taltech, Syke, and from Russian side Zoological Institute and other. So the institutions that involve are Russian Academy of Sciences. So the overall objective of the project was adaptation and implementation of uniform biological indicators for assessment and control of environmental quality in the area, and the main output, one of the main output would be the standard approach strategies for transnational monitoring and assessment of emerging chemicals and selected emerging chemicals and harmful substances and their effects. In the objectives in more details, so we have to fulfill the existing gaps in the studies of priority substances in the study area, and we have been compiled the available data from neighboring countries and collected additional data from hotspot areas. We have applied numerical modeling to show the spatial distribution of hazardous substances, mainly from such sources as rivers, atmosphere, and implemented the assessment of toxicity to biota with a set of effect indexes by conduction of different exposure studies, like organotids or pharmaceuticals. So on the map you can see the sampling stations we have visited during the project. So the program was quite extensive. We have used research vessels from Russian side, from Estonian side, and we have combined different samplers in the water environments, sediment and biota, visited many locations, but there was a problem. Initially suggested quantity of biota was not achieved due to scarcity of benthic invertebrates in some stations, and we had to shift from one matrix to another, and we have collected all possible material we could. So on this map, actually, you can find different sampling environment we have where we have conducted the sampling. So the biota we have collected in most stations anyway. And new data collection, we have analyzed it and tried to extrapolate on the area we have studied. And I will show some results a bit later. Also, we have conducted laboratory exposure studies. So there will be physiological markers of hazardous substances, biological effects, like determination of respiratory activity. We also look at the cardioactivity of mollusks. Russian colleagues mainly done on bivalve mollusks. And also extensive BOSS caging approach we have used. We have made quite a lot of ecotoxicological tests of sediments, where we have looked at the mortality, reproductive disorders of amphipods. As well, we have looked at biomarkers, and we have used species of amphipods. So some of them are local one species, some of them are invasive species, but we have tried our best to get the effects and to get the responses of, for example, biomarkers. Caging approach, so we have different species also used in cages. For example, the blue mussel or dry senna mussel, as well as freshwater one, Unio. And so on the picture you can see they are representing the activities we have done. So installation of the cage. The cages was the most might be one of the hardest NAGO work we have done. Results. Some of the results are already published. For example, so on accumulation of hazardous substances and other pathways from potential sources in the Gulf of Finland. So in this publication we have done the modeling, and we looked at simulation of sedimentation from main river basins across the Eastern Gulf, and results indicate that even with a very small settling velocity, it is hard for hazardous substances of riverine origin actually escape from vicinity of river and accumulate in the deepest areas of the Gulf. So the particles with heavy particles with substances, hazardous substances, will fall near the sources of rivers in deltas. One more result concerning the indicator substances in the sediments. We have found that in the several stations the cadmium was exceeded the HELCOM threshold, and in the most stations we have sampled the toxic organotin TBT exceeded manifold the HELCOM threshold suggested, and as well the pH anthracene in most of the stations we have sampled as well exceeded the threshold values of 24 microgram per kilogram dry white. Some more results which have been published. So on pharmaceuticals, for example, we have found such pharmaceuticals in the eastern part of Russian side of study area, like carbamazepine or ketoprofen, are prevailing in the water samples and quite widespread in the area. Ketoprofen is anti-inflammatory medication, and carbamazepine is anti-epilepsy, I think. Yeah. One more result is on exposure study with diclofenac. So we have found that the exchange of minerals between the organism and the environment is deprecated when this organism are exposed to diclofenac, even quite low concentrations. And conclusions on outcomes so far. So chemicals residues continue to affect the state of environment. Persistent organic pollutants and heavy metals accumulate in areas, so they are impacting the sediment-dwelling biota first and accumulate through the trophic chain in the study area as well, we can suggest. Some substances like heavy metal lead in sediments closely approach in some matrices the threshold values, while some exceed manifold, as anthracene, mercury in biota, lead in biota, cadmium and TBT biota and sediments. Actually, we have to keep in mind the rate of sedimentation as hazardous substances disperse along the shoreline in the Eastern Gulf much further than initial release. And the gradient is important to take into account when we're planning the monitoring activities. I also put a slide on future collaboration that might be in the area. So the joint screening campaigns in the emerging or established hotspots like large ports, shipyards, centers of recreational activities. So we have to combine reliable approaches in hydrological, chemical, and biological effect monitoring across the Gulf, and of course to study environmental background, oxygen conditions, continuous survey of contaminants, mainly in offshore accumulation areas, and apply the cost-effective biological effect monitoring approaches on subcellular individual levels with available local species, or implement the caging approach. Finally, to develop regionally optimized integrated approaches for the monitoring and assessment of the health status of the Gulf. Some possible funding opportunities of trilateral collaboration, the Horizon Europe goals and special terms for launching Russian partners. In EU Interreg programs, where we can look at targeted issues, pharmaceuticals, for examples, cross-border cooperation program concerning Estonian Russia or Southern Finland Russia areas, or other EU goals like biodiversity. The project proposal preparation is currently ongoing and will be led by the partner from Finland. Of course, the joint activities funded by national ministries, foundation or other research funding agencies are possible. Thank you for your attention. So I think I'm in time. If you would like, you can go to the webpage of the HASLESS project and find the detailed information on activities and fields.
Thank you very much, Ivan, for the really interesting presentation. We have time for one short question, if you have, please.
Actually, it's not a question, it's just a remark. Congratulations, you have a very great results, which we were, as geologists, we were waiting for a long time. As you know, maybe we have no sediment quality standards, neither in Finland, nor in Russia, neither in Estonia. And actually, about the future cooperation, we have something to discuss, it seems to me, because it's very interesting results, and we were planning such a future cooperation for a long time. So congratulations.
Yes, good. Thank you. Yeah, definitely, it can be discussed. Yeah.
Thank you. Okay, thank you very much.
Thank you for having me.
Our next presentation is called Seals in the Gulf of Finland, a status review and perspectives. And it's by Mart Jussi. I understood that this is online presentation. Yes?
Yes.
Okay, please, the floor is yours.
Thank you. Good morning, everybody. I'm going to talk a little bit about seals, because seals as marine top predators have been acknowledged as suitable indicator species or species group for marine environments and their health and condition. And we have been studying seals in the Gulf of Finland now for 25 years in a certain cooperative network. And the last 5 years have been rather intensive with several applied studies that I would like to bring to you today, and a little bit then open the backgrounds why we need to study the seals together. So there are two species of seals in the Gulf of Finland. In that sense, the Gulf is very rich in seals. And the both species have their own statuses and problems there that are of importance when we want to understand what is the environmental condition or the status of the Gulf itself. So my computer, for some reason, refuses to change slide. Sorry, this hung. Ja, nu tyks slider ovat. Yeah, I'll just tell them the slides will be changed then from the headquarters. Okay. The first slide is about the status of the ring seals in the Baltic Sea in general, and particularly we have to pay attention to the status of the ring seals in the Gulf of Finland, because the ring seals can be divided generally in like two big groups or subpopulations in the Baltic. The northern population, which inhabits the Gulf of Bothnia, they are quite numerous, still over 10,000 individuals, and there is a slight increase the status is not the best, but still quite optimistic. While the other three, the southern populations that inhabit just South Finland, Gulf of Finland, and the Estonian west coast, they are small populations, quite separated from the others, and all of them are rather small. So if we look them separately, then the Finnish population, the Finnish the archipelago sea, is just a couple of hundred strong, and the Estonian west coast population is approximately 1,000 strong. But here we have to point out the Gulf of Finland, the ring seal subpopulation, or the small isolated population that really is only a little bit above 100 individuals. And in the world scale, this is very, very rare and vulnerable population, because the iconic species like Saimaa ring seal or the Mediterranean monk seal that are considered to be critically endangered in the world, they still are found in 300 or 400. So basically we're talking about the extremely small seal population. Next slide, please. And we have done some service conditions allowing, of course, already since 90s, using a standard method of counting seals over ice fields from airplane. And this is a quite robust method, but gives good results if the research effort is sufficient. And from this table, you can see that if the minimum effort should cover like 10% of the total ice area in Gulf of Finland, we have succeeded to exceed that number. So whatever result we get is quite representative. And the right column then gives the population estimate. And as you see, since the recorded times, the top number, or the biggest population estimate, comes from previous year, and it is 100, and I cannot see it myself, but about 130 individuals. So this is really a very small population. Next slide, please. And the other work we have been doing is by using telemetry tags, we have tried to find out the whereabouts of the seals, how they use the sea area, where are the core habitats, and are there exchanges in between different parts of the Baltic Sea. And here you can kind of overview picture of all the 23 instruments that we have used on seals. And as you can see, the area is very much restricted to the eastern part of the Gulf of Finland, and the connections to the west are quite small. And I would like to emphasize that the 23 seals that we have marked, theoretically, it is 1/5 of the total population, because we don't know that we have been catching the same animals twice. So basically, we have marked quite a big proportion of the very small population. Next slide, please. And if we look at the individual seals, then you can see that they really can be very, very local in terms of their home ranges. It only is up to some 100 square kilometers, and they stay there during the very long period. So they are very local, and it means that whatever happens in the environment, they are very open to that influence. And just these are two individuals as an example, but we have this understanding that they live in smaller social groups. Then we can assume that this kind of restricted movement is representing not the whole group, but at least not only individuals, but this is how they use the sea. Next, please. And by looking at the behavior, we have lots of oceanographic data coming back from the tags. We can distinguish between the rest and active periods, between feeding and breeding, etc. And here we have like outlined the main like biological key habitats in the Gulf of Finland for the ring seals, for this very small population. And you can see the black square in the Kurgalski and the Russian Islands area represents the core habitat, the core area where they stay all the year round, while the blue squares show like satellite areas where they are found in summer, where they forage, where they eat fish, and the red the square denominates then the breeding area on ice in the northern part of the Gulf. So you see, in the terms of the international cooperation, there are the functions of the seals are also divided by different sea areas and countries. So we have to make a common effort to understand the life cycle and the functioning of the environment and react accordingly. Next slide, please. And And if we look at the possible connections of the seals to the other parts and sea areas, then there's a good example of always there's a kind of a crazy mouse in the lab. That if you are already getting an understanding of how the seal system works, then usually there's one guy who spoils it all, and we had such individual in our sample too. But it's just interesting, but also significant to understand how the seals are using the sea. This individual was staying in the core area most of the time, and then suddenly in the autumn took a trip to Estonia, and then went back straightly, just came to Estonia, made a couple of rounds and went back to Russia. We don't know why it did it, but they do such things, and it's good to know that these things happen because they may share some light into the degree of isolation of the populations with the possible consequences of gene drifts, etc., and the possible scenarios of becoming extinct or surviving over longer time periods. And there are just some numerical data indicating how dedicated the seal is when it goes to one place to another. So it all happened in a constant linear movement of 3.5 kilometers per hour, and for several days. So these guys are very capable of moving in the sea. Now the gray seal is a different species with different status in the whole Baltic. It's mostly inhabiting the whole Baltic Sea, but it can be found more in the northern parts of the sea, including Gulf of Finland. Next slide, please. Yes, next slide, please. And with the gray seals, one main observation that we have had over the time is that the number of gray seal in the Baltic Sea has increased since we started to work with the seals a couple of decades ago, and during the last 5 years, as I mentioned, we have put more effort into the internationally coordinated counts, and we have realized that when the number of the gray seals in the whole Baltic has increased, let's say, 2 times, then in the Gulf of Finland the same has happened, but the increase has been like 4 times. So proportionally, the increase in the Gulf of Finland for the gray seals is very high, and that brings about new challenges to the conservation and management of the Gulf, because the species has not been abundant there before. Historically, it was a ring seal Gulf, but nowadays the ring seals are going like not becoming extinct, but they're becoming very rare, and the gray seal is like coming in. So we are seeing a big change in the environment with some applications than for conservation and ecology. Next slide, please. And if we look at the gray seal habitats, we don't have this very fancy telemetry projects done with them in the Gulf yet, but we see that there are very good suitable gray seal habitats available in the Gulf and already taken into use by gray seals. So this is how it looks like in the southern parts of the Gulf. This is pretty much as we have also in other parts of Estonia. And the next slide will indicate how it looks like in the northern part of the Gulf of Finland in the Russian Sea area. And this is the granite rocks. They are very typical for that kind of coast, and this provides them a really abundant habitat that they could occupy. And as I said, the numbers are growing. So next slide, please. And one of the concerns that we are now facing, not only us but the seals too, is that the winters are becoming warmer, and both the species we are talking about are ice related. They are ice loving seals. They need ice for their reproduction, for successful breeding. But these kind of winters, like traditional Gulf of Finland winters, when you can walk over the Gulf from Estonia to Finland, have become extremely rare in the past decades. And it influences our research effort because, as I wrote here too, it's not only the favorite key habitat for the seals, it's also the favorite key habitat for the seal biologists. So we are running into some problems regarding the research we are doing. Next slide, please. Because the modern winters, the modern springs, April, the sweetest time to look at the breeding seals or the molting seals, to count them. Usually the ice melts already in the Gulf, leaving us without vital information. Next slide, please. So just to sum it up briefly, it is that the ring situation in the Gulf is really very critical. The species might become there locally extinct and replaced by another seal, and we have to do quite an effort to understand its demands for the environment and habitats, and try to see that in all three countries these demands are taken into account in different ways we use the sea, including the marine spatial planning, let's say, not building maybe windmills on the crucial seal habitats. The gray seal is moving in, and basically it's putting some pressure on the seals too, because the situations between the relation between fisheries and seals is pretty bad, and the gray seals tend to be the species behind the conflict, and the ring seals would suffer from the increase in conflict. So we have to be aware that this conflict will escalate also in the eastern part of the Gulf of Finland. And well, I cannot see my slide myself, but just to conclude that the seals are a very good instrument to study marine ecosystem. Also, they can be used as platforms for putting sensors and letting them to study the sea for us. But this all can be done and must be done in cooperation, because it's quite a challenging work, and it very often takes people from different countries and disciplines to solve these challenges. So we have been studying seals and cooperating now for 25 years. So I wouldn't say we need a new start, but we need definitely a more dense cooperative network around the Baltic that addresses the problems with the marine mammals. Thank you for attention. Yeah, last slide, please. Yeah, you can.
Thank you very much for these really interesting results. You managed to keep also the time schedule very well, so we have again a time for one short question, please. Okay, I can see that. Please, there is in the back. Yeah.
Yeah, hello, Mart. So I would like to ask about how the contamination is affecting the health of the seals in this area you have studied.
There have been no dedicated studies in the Gulf of Finland so far. I think that is one of the potential further areas of cooperation and research, but we know from the other parts of the Baltic that the ring seal is rather sensitive to contaminants. And looking at the very small population in the Gulf of Finland and knowing that contaminant loads have been there historically very, very high, I think it's worth of looking into their health. That does their health allow them to recover? Because we see some pups every year, but the number of offspring doesn't quite support the very small population. So that is one of the priority fields, I think, for the close future, that if there's interest and possibility, we have to look into the health issues, namely in terms of pollutants.
Thank you very much, and applause once again. Thank you. And our next presentation is called Ecosystem Services in the Gulf of Finland, the approach of the Maria project by Susanna Jänberg. And this is also online presentation. Susanna, can you hear me?
Yes, I can hear you.
Fine, please. The floor is yours.
Thanks a lot, Heikki. It's nice to be here, even though I'm online, but still it's really good to be here today to present our project called Marea. And I'm going to give you a short overview of our activities, what we are going to do in the project. It's a collaboration project of 3 countries and 4 partners. sorry, I have a technical problem because my screen is saying that I'm disabled to share because someone else is sharing. Okay. Great. Okay, thanks. So yeah, it's a collaboration project. Finnish Environment Institute is the lead partner, and then we have Pellervo Economic Research, Baltic Environmental Forum, and University of Tartu as the collaborators. And we are being funded by Interreg Central Baltic from the EU. And MAREA comes from Marine Ecosystem Accounting to Integrated Governance for Sustainable Planning of Marine and Coastal Areas. And we have been running the project for one year now, and we have still one year left. So very exciting days to still come. And now today I'm going to talk a little bit about our ecosystem services approach and also the other activities in the project. So the idea for the project came from the challenge that we have been facing for decades now, that we are really having difficulties to achieve sustainable use of our natural resources. And there have been a lot of initiatives to tackle this problem. One of the maybe quite holistic frameworks has been called ecosystem approach. And the basic idea here behind the framework is to take holistic point of view of ecosystems and its resources and the society using those resources. And the Convention of Biological Diversity defines the ecosystem approach as a strategy for integrated management of land, water, and living resources that promotes conservation and sustainable use in an equitable way. So great opportunities would come from the ecosystem approach, but of course it requires a lot of information. And as researchers, is our responsibility partly to produce that information for that ecosystem approach. And some of the information that is needed is listed here. For example, we need to know about the ecosystem state. We need to know about the supply and use of ecosystem services, and then of course about the links from human activities and their pressures to ecosystem and its services. And of course, then we need to integrate all of this together. So in MAREA, we are taking some aims towards this approach. Our first aim being developing the ecosystem service mapping and modeling. And now when we are talking about ecosystem services, we are talking about all the benefits and goods that come from the nature or the natural resources to us, to human societies. So we can talk about, for example, food, or we can talk about carbon binding and sequestration that benefits then our climate initiatives. So also marine ecosystems produce these benefits. And here's a famous picture from Pochin and Heines-Jan, who have in their cascade model tried to define a little bit how the ecosystem services are flowing from the ecosystems. And you can see that on the left side, there have been listed biophysical structures and processes and ecosystem functions. And those are the ones that we as natural scientists can actually try to model and try to produce with our data and tools. And then when you follow the cascade, then those biophysical structures and functions lead to final services that are the actual ecosystem services that we can try to measure. And then finally, we can include more social scientists and economists, and we can try to define the benefits that are actually coming from the services and then value them monetarily or in some other ways. And of course, we are in a good position because we are having a nice collaboration. We have a lot of data already existing, a lot of knowledge behind us. So we have, of course, used many of the previously run projects in all of these 3 countries. So, for example, we have had Meriavan project that has defined different habitats and species and their links to different ecosystem services. So this was a literature-based study and expert knowledge-based study about the general overview of the ecosystem services. Then we, of course, have a lot of different biophysical data. Here are only just few examples. We have the marine inventory, underwater inventory program that's available, that has been running in Finland for many years. We have a lot of biological data coming from the project. And of course, then we also have a lot of data coming from Estonian and Latvian side. And here's just a picture of some data points from Estonian side. I printed this figure from Planwise for Blue tool. So it was, if I remember correctly, it was about focus places where they have found focus. So a lot of data, but of course we need some additional data for things to come and go smoothly. So we have planned a survey that is targeted to coastal visitors. This has been running the survey during the summer in Estonia and Latvia, and it's mostly about the recreational activities along the coastal areas. Then we are planning to use some social media platforms and analyze the picture contents and places that are listed there. This is a bit still under investigation. Unfortunately, I'm not sure if we are finally able to do this, but now we are exploring the possibility to a little bit add to our other modeling activities. And another example from satellite images, some common read data that we can use also for modeling. Here's just a list of modeled services that we are aiming to model in our pilot areas of Gulf of Finland and Gulf of Riga. Some regulating services such as blue carbon, so the carbon sequestration and storage, some ferromanganese concretions, then provisioning services such as common reed harvesting and focus compounds or focus, some compounds that can be used for example, some pharmaceuticals coming from focus. And then cultural services, recreational opportunities and aesthetic services. But not only this, we are also looking at some human impacts that are possibly affecting the services. This methodology is based on the paper published by Kotta et al. So we are also combining of the human pressures and then looking at how they are affecting the ecosystem, but then also possibly the ecosystem services and values that are coming from the services. Okay, our second aim then, it's a little bit different. We are also looking at a little bit about the benefit and monetary side of ecosystem services. So we are developing the concepts of ecosystem accounting framework in the Baltic Sea environment. And here our aim is to test the natural capital accounting concept in the pilot areas, so in Gulf of Finland and Gulf of Riga, and link the maps of ecosystem services that I just talked about, the modeled ecosystem services, to already existing data sources of relevant economic sectors. And here's just a figure from the system of environmental economic accounting developed in UN, and also it's being adopted around the world, for example, in EU. And the basic idea here is to try to include the natural resources to systems of national accounts so that we would know how our natural resources are doing. And here's the accounts that are included in these accounting frameworks. So ecosystem extent account, ecosystem condition account, the ecosystem service supply account, and then the monetary account. And as you can see that we are trying to contribute also to this framework. At least we are exploring the ways that we can contribute here. So we are trying to value some of the services such as common read, use, then blue carbon again, and cultural services. And we are also preparing a survey about the valuing the cultural services in all 3 countries. And here's an example of the trade-off analysis that we aim to do. So if we think about the common read and its extent, there are many ways that we can use common read. There are a lot of different benefits coming from it. For example, cutting of it for building material, or then we might have some cultural benefits, and then of course some habitat benefits as well. And these all uses may have some trade-offs when we start using them. So it's a balancing exercise as well, like what should we do? Then our third aim is maybe taking a little bit even more holistic way. So we are creating a sustainability compass about the sustainable development goals. This is a list. This is an indicator-based tool. So we are developing a list of indicators that could be used by different marine sectors that are interested in benefiting from the marine resources. And the aim here is to provide them a tool. So this targets the marine sectors such as wind farms and aquaculture. And the indicators are collected to represent the human well-being, economy, and ecosystem state. And this will be a web tool that can be easily used. And it will provide not only the natural indicators, but also the indicators from these other aspects. And this is mainly developed by the Pellervo Economic Research, and it will be very interesting to see how the tool will then be used by possibly the different sectors. So a lot of things going on at the moment. Our fourth and final aim is to build a decision support geoportal where we aim to put all our results that we have produced in our project. And this is actually already existing portal, Plan-wise for Blue portal, where Marea project is then contributing. We are particularly concentrating on the ecosystem services modeling, and we are adding layers to that tool and making it a little bit more complex and allowing the user to make more analysis with the already existing data and the new data layers. So if you're interested in the tool, you may go and see how the tool works already. The address can be seen there. So thanks a lot for listening. If you want to hear something more, you are free to send me an email or follow us on Twitter or visit our nice website on marea.balticseaportal.net. So everything can be seen there. And of course, now I didn't present any final results yet, so also the results then can be found in our website when we have something already there. So thanks a lot for listening.
Thank you very much, Susanna. Applause. And again, one very short question concerning this very, very diverse project you just described to us. So please. Okay, in case no questions, many thanks once again, and we turn to the next presentation. It's by Robert Abs and his colleagues and called Linking Marine Natural Values and Underwater Cultural Heritage to Promote Sustainable Blue Ecotourism in the Gulf of Finland, Baltic Sea. Please, the floor is yours.
Thank you. Good morning. And we are now proceeding with linking marine natural values and underwater cultural heritage to promote sustainable blue ecotourism in the Gulf of Finland, Baltic Sea. Here are some important keywords like natural cultural heritage values and sustainability, blue ecotourism. It means a number of important keywords, and in the Gulf of Finland, naturally. So, first of all, ecotourism, a sustainable blue economy, is creating tangible opportunities for new jobs and businesses. This is one of the important directions nowadays. And tourism is an important sector in blue economy. Ecotourism is an emerging alternative to the mass tourism, with reduced negative environmental impacts and higher benefits to local communities. Reduced environmental impacts and higher benefits to local communities. So, and speaking about ecotourism, the main characteristic of ecotourism is its objective to promote nature conservation through a principle of protection through usage. This is very important to underline this objective, protection through usage. It means that we are not closing the areas with very high values, but we are protecting them through allowing tourism to come in. In ecotourism activities, the use of participatory tools, such as citizen science, is very useful to collect data at a low cost while involving local communities and educate visitors and industry value chain. It is also important, this connection to the local communities, visitors, and industry value chain. So, and sustainable blue ecotourism is contributing to creation of socio-economic benefits for the local community while preserving natural ecosystems. It was said once more to underline these connections. And I'm going just to present you a developed in a course of Interact Baltic Sea Region Baltic Rim project, has developed the user-friendly participatory GIS web portal. You can enter that anytime, and the aim is to provide marine eco-divers with background information on sustainable marine eco-dive destinations connected to marine natural and cultural heritage assets. Participatory GIS portal supports eco-divers and groups of other stakeholders in geographic problem solving and decision making. It means that not only eco-divers, but wider circle of interested stakeholders can use that naturally. And this is how it starts. And here are some explanations. We have, naturally, we have zoom in and out. And here we have environmental data, protected areas, underwater cultural heritage, and administrative boundaries. Because of time limits, I will not go into all these details now, but you can do it when entering. Environmental data, nature protection areas, underwater cultural heritage, administrative boundaries, in more detail here. And now, step by step, environmental data, and here, water transparency. It is very important for especially for eco-divers, that water to be transparent enough to allow the enjoyment of the underwater natural and cultural values. So then environmental data, here species richness, it is modeled. We did together with Finnish partners in the project Plan for Blue. It means that if necessary, next step, it can be this system can work also for the Finnish waters here, and it is quite promising signs shown even here during this conference that we can add the Russian side map layers here. So then moving, this map is species richness of benthic flora. For those who are interested in that aspect, then environmental vulnerability profile. It is important map layer showing where are the red points vulnerable, especially vulnerable parts of that. So, and at the same time, when looking into this portal, you can click on some places, like here. It is nature protection areas and Apollo, in Estonian water, Apollo shallow nature protection areas, and you can get immediately access to the official data related to that, and you know, in the official registers of Estonia. So another example here, underwater cultural heritage. We have data here from Estonian Maritime Museum, and then cultural monuments, official, and cultural monuments in polygons and points. And here you can see, if clicking on one of those, you can see underwater cultural heritage data from so, and name of the vessel, and much more information to be seen. The same story here. You click on the object. You can see that this is lava wreck Stella. It could appear in different languages based on what is the basic language in your computer. So, but because my computer is in Estonian, it is showing Estonian. So, and here moving further, here they are, and water transparency and the monuments and all this underwater cultural heritage. People can see from this where are the good enough transparency situation in the area and where are the objects they are especially interested in. So moving further, species richness and underwater cultural heritage, overlays, and so on and so on. You can zoom in, out, read all this official information about those. And to conclude this presentation, we may say that MCH, Marine Cultural Heritage for Blue portal. For blue, it means that to serve blue economy, eco-tourists, eco-divers. Presents the data of marine natural values and maritime underwater cultural heritage that are publicly available for eco-divers and sustainable ecotourism in general. The data is publicly available, open, and all stakeholders can use that. These data are publicly available also in support of the strategies of medium and long-term maritime sustainable ecotourism development to enhance its growth, consolidation, and sustainability at local, national, and regional level based on the need of the local communities, again, through participative workshops, capacity buildings, and inclusive processes. This portal can be used for all these workshops, all these participatory processes. And I would underline finally that we have been, we know already about this ecosystem services project, and this environmental part is the, let's say, cultural services of the area, but at the same time, speaking about the underwater cultural heritage, it is the impact of that, of using, is the term, it is supporting cultural well-being of society. Thank you very much.
Thank you, Robert, very much for this really interesting presentation. And then we have time for a couple of questions, so please.
Thank you, Robert, for this extra exciting, very exciting presentation. What is the difference between diver and eco-diver? Because in Russia, in our legislative frame, the coordinates of underwater cultural heritage are closed, because we are not sure that our divers are eco-divers. So what is the difference and how to define? Thank you.
Yeah. We have no official definition of that yet, but when speaking about mass tourism, this is about all divers. They are diving in mass, and they are doing everything there. But ecotourism is, protection through usage. It means that eco-divers are diving, enjoying all these things, and also are part of the protection of the objects, of the nature and the cultural values. And they support this part of the story. This is the difference. Yeah.
One more question. Still we have time for that. If not, thank you very much once again, and applause.
Thank you very much.
Then we go to the last presentation of this morning's session, Perspectives for Integrated Multi-Trophic Aquaculture in the Gulf of Finland, and it will be presented by Georg Martin. Please, Georg, the floor is yours.
Sound check. Yeah, good morning, everybody. So it's nice to see so many people here after so nice reception yesterday. So at first I would like to thank Kai and Tarmo for this excellent possibility of having this nice workshop. I have been myself involved in this Gulf of Finland cooperation, I think, from almost the beginning or from the beginning. So I have been working with different topics here. So it's nice to see that we can have now continue that, and it's really nice to see people for a while, not only foreign guests, but our own colleagues from other institutes. So we have not seen for a year for now or something. So when preparing for this conference, we were thinking that what we can present here. And I decided to pick the topic we have been now working for some time, for some years now. It is the blue growth, and everything what is connected to that is quite good and high topic nowadays. And there are several very known and important subjects in this bigger topic. And besides wind parks and other developments, the aquaculture things seems to be very high on the agenda almost everywhere. Especially in Estonia, we have a case at the moment that this seems to be something which is interests a lot, both developers, ministry officials, and also scientists nowadays. So I will be talking about a couple of, we have several projects ended, and a couple of projects running at the moment, which are all connected to this subject. So this will be like a compilation of different things here. So what is status with aquaculture in Estonia? So we have about 50 companies who are registered, who have licenses for aquaculture. Among them, 24 are, this is data from 2019, so quite reasonable fresh. So we have 24 enterprises who have license for cultivating fish, and about 20 who have licenses to cultivate crayfish. So on this map you see the dots, every dot is a one license, and you can see that most of them except one are located on mainland. So the one is, it is truly marine one, is located in northern coast of Saaremaa. And they have been working there, or this license and this production has been there for quite many years by now. And what kind of aquaculture we have, you see from the table below that, it has been rising from year to year, but it's still quite modest, so about 1,000 tons per year altogether. The main cultivated fish is rainbow trout, which compose about 90% of the whole amount. Others are very, very much smaller amounts. So, but that's the situation before. So, and this is a map taken from our Marine Spatial Plan, which is going to be endorsed very soon, this month or December or January. And the marked there, the shaded polygons are applications for building permit. so which are already submitted. And these are mostly two things. These are wind parks and aquaculture. And you can see that there is actually over, I think that there is 15, 16 locations where we have now applications for fish farms. Some of the locations include several applications, so some guys are thinking that it's a good idea to put several companies or several applications beside each other. So, and the total amount of production for this, if you just sum everything up, it's over 30,000 tons. So compare that we have like 1,000 so far, and it's over 30,000 applications. So actually, it shows that there is a really huge interest to develop this topic. And you can see that there are some of the locations are also in Gulf of Finland, but there is also locations in Gulf of Riga, which is the southernmost is a combination of wind park and aquaculture, which is also quite interesting case. And then there are several applications facing the open Baltic. So what are those applications? These are actually a mixture of very different technologies. So you can have, nowadays aquaculture technologies are many different ways how to do that. You can have a land-based fish farms, and actually there's besides many truly terrestrial land-based ones, there is one application which is located close to the sea. So idea is to use seawater for aquaculture, but still it is land-based one. So this can be quite big one. Then this the very traditional ones, these are open net farming. So this is like you have a big net cage put in the water, you have fish in it, so there is natural ventilation by water, so water movement. So, but obviously it's also that everything which is left over from this fish production, which is also, it also goes to the environment. And then there are some new versions, that like a floating bag concept. This is a Norwegian new technology, which actually it's like it's located in the sea, but it's like semi-closed. So it uses seawater, but it's also there's a possibility of filtering the water, treating the water, so its environmental impact is much lower. And finally, there is, of course, one of the Estonian applications is based on the ship-based concept. So there's the basic idea is that you have somewhere in the sea you have a anchored bigger ship or construction which is like ship, which can be moved if needed, can be repositioned if needed, and so on. So again, everything is contained in a one hull, so it's easy to treat and to manage the thing. So of course it's much more expensive than the open traditional versions, but this still has much lower impact on environment potentially. So, okay, we have a big number of applications, but as it's not only Estonian officials, but I heard also that the Finnish and in other countries officials have a problem with issuing those licenses, because all Baltic Sea countries have agreed that we will not pollute Baltic Sea more than we are doing it now, or actually we have agreed that we will cut down the nutrient loading. So there is a problem. So how to do it? You have on the one side, you have obviously interest in developing of this blue economy. You have huge interest from developers, investors to use this resource, what we have, these sea areas. But on the other hand, we have agreed that we will not pollute more. So we have to find the solutions how to come out of this issue. And there might be a solution, but or one of the possible solutions, and this is integrated multi-trophic aquaculture systems. What is it? And basically, it's actually the idea when you combine in a one aquaculture unit different organisms or different trophic organisms belonging to different trophic groups. So the idea is that what is left over from one type of organisms is consumed by others. And if you combine like finfish, benthic deposit feeders, filter feeders, and algae. So potentially the idea is that you can actually consume most of the nutrients you are actually adding to the seawater. This concept is not very new, so this has been around for quite a long time. We don't have in the Baltic similar applications so far. There are reasons for that. The main reason, I think, is that okay, we know what to do with fish, but we have no idea what to do with algae or mussels or other organisms which can be part of this system. So there is no market demand for that, so there is little interest from investors to do that. But now, in these new conditions, that we actually have a wish to have this fin fish farming, and we have obviously have money around, so and we have also some possibility of regulating something, so there might be a chance. And also the new developments, we have been working in different projects now that there are coming slowly new applications also for other species, not only fish. So we are learning how to use mussels, we are learning how to use our algae and other things, so combination of that might help. Okay, some ideas or some results here. This is a work by my colleague. This is modeled estimation of Mytilus or blue mussel farm productivity, and it's a map of, we have a map for the whole Estonian Sea area. This is an extract for the Gulf of Finland. So you can see that there's a possibility of having a quite good yield of Mytilus from the long lines, so up to 2 kilos per meter of line, so which is actually quite a lot. So, and this is how it was modeled. So it's basically relationships between basic environmental factors were used to model it on the spatially. So you have differences in different areas. The similar modeling was done for algae, and here is an example for ulva. Ulva is a quite interesting species and very perspective for aquaculture purposes. It's growing quite fast. It assimilates nutrients very fast, and so it's and this is also similar kind of modeling exercise for open or free growth of for free growing of ulva in the water. So you can see again there are different areas which seem to have better conditions for that, but this is in the open sea. So. And this is how it was modeled. So the percentages here below the graphs show what is the environmental factors which actually are responsible for how much they are, how important they are for this algae. So you can see that for ulva, the sun radiance, temperature, and nitrogen seem to be the most important things to have to be fulfilled. So then we have tested land-based setups. So we had a project which is ended now, but it was quite interesting. We used tried treating of fish farm effluents by cultivating macroalgae, and actually achieved nice results. So we had on northern coast of Saaremaa Island, we had a big setup of it was like a mixture of fish farm and algae farm. So we had one tank stuffed with fish, and then we had this effluent there. It was like normal fish farm working, and then we treated it, pumped it through the macroalgae, or we tested different species. But finally, and this is how it's in work, and finally we got quite nice results. Ulva turned out to be the best species to be used. It has a high nutrient uptake, fast growth, long vegetative period, so can grow unattached and so on. So it's very good species to use in this kind of setups. And we achieved the best conditions, like 4% biomass growth per 24 hours, which is actually quite big. But in literature, you can achieve even more. So yeah, that was one. So actually, this very perspective algae to use in this kind of setups. Then we had this year, we had it was a desktop study, but we Together with a Norwegian colleague, me and Jonne Kotta, we were participating in that setup, in that study, modeling algae and mussels. So, and we concentrated in this study on this new technology, of these floating bags, and actually came up with some very nice calculations. So, both for mussels and algae. So you can actually include in the cascade system finfish, mussels, and macroalgae, and you actually achieve quite. Okay, I will skip that. I'm just getting. My clock shows 2 minutes, but you said okay. So I will skip these. This is actually, yeah, I'll go to one of the final slides. So finally, we achieved that compared to current requirements we have in our Water Act, that we have a certain limit how much nutrients you can put in the water per 1 kilo of fish. So using this combination, tanks with water filtration, with mussels and with algae, we are able to cut down the nitrogen effluents by 60% and phosphorus up to almost 90%. So actually it is quite good setup. Besides that, we have a quite big amount of biomass, both Mytilus and ulva produced, so we can actually something to use. And conclusions, so it seems that this integrated multitrophic aquaculture concept might be a perspective thing nowadays. It can be applied in very different aquaculture setups, and it would be nice to have the experimental setup, having actually near real size farm to use it and to test it. And of course, the separate studies and separate work should be done with how to utilize the produced mussel and algae biomass from there. But there are also some options for that. So, okay, thank you. That's all from me.
Thank you, Martin, very much for the nice description about the situation of agriculture in Estonia, and also, it's working, about the possible ways how to solve the problem with the nutrient loading related to this, maybe increased production. But now there's time for one question. Please.
Sorry that I have so many questions because I'm MSP specialist, so it's a very interesting concept that is proposed there. Do you know about some financial, maybe not financial support from the governments of the European countries, or maybe out non-European countries to promote such a technology of multi-use of, okay.
No, actually, nowadays there are different European instruments to utilize here. So there are different funding systems also for this developing of new approaches in aquaculture. Actually, we have been using these exactly for these projects here. These are national, or they are European money, but distributed nationally. I'm sure there's possibilities also for international funding to look for that. For example, Horizon New Call at the moment, we are also participating in one proposal where there is exactly, which is directed for this development of this new marine food, so types of things. So there are several possibilities for that.
Okay, thank you very much. Applause once again.
Thank you.
Okay, this is the end of this session. I would like to thank all the speakers, and also thanks to those who made very, very interesting questions. We are now about 8 minutes late, so you should be back in 10:45. Now there's time for coffee break. Thank you.
devoted to the findings of the early career scientists. And we have 4 presentations today. The first one will be online, and the 3 others will be here, presented offline. And 2 of them are devoted again to microplastics problem. The third one will be about the underwater landscapes and using GIS technologies, and the 4th will be devoted to the marine spatial planning in the Russian Federation, some approaches to it. Since we have 1 hour and for presentations, so I ask each presenter to spend not more than 14 minutes for presentations, so that we have at least 1 minute for questions, because that's the point, to discuss the presentations, not only to present them. So first speaker is Yuri Tironiemi. Is he online? Hello? The floor is yours.
Hello, I'm here. Hello, can you hear me? Okay.
Yes, we hear you.
So, good day to everyone. So good to see so many people joining Gulf of Finland Science Days. My name is Yuri Tironiemi, and I work as a researcher at the Finnish Environmental Institute, and more specifically in Marine Center. But today I'm going to talk a little bit about my thesis, my master thesis, which topic was microplastics in Northern Baltic Sea bottom sediments. And as a supervisors, I had Outi Setälä and Maju Lehtiniemi, also from Syke. And I have divided my presentation into 3 main parts. First, the aims, then the study itself, and then the results. So my aims, I had 2 carrying main themes. First of all, I wanted to know how microplastic concentration in coastal soft bottom sediments. And I had 2 set of samples. I had 7 samples from locations close to the 6 coastal cities. So from all the way from Vaasa to Kotka. But I also had 7 samples from Pojo Bay, which is marked with yellow circles. And the Pojo Bay is a semi-enclosed bay in southern Finland, close to Helsinki University's Tvärminen Zoological Station, so you may be familiar with that one. And as a second main carrying theme, I had testing and developing methods for monitoring. And like many of us know, MSFD obliges member countries to monitor state of the seas, and for wanted to test how to best to monitor 2 sediment samplers. And I tested the extraction process of microplastic. Mesh size had an effect on results, and I then tried to how to detect, measure, and quantify microplastics. And here are 2 pictures of the sediment sampler. So on the left, you can see the Gemax corer sampler, and in the center picture, you see petit bonar crab. So from all the sample locations, I had the petit bonar crab, and from 3 locations in Pojo Bay, I had also the Gemax corer samples. And on the right side picture, you can see the freeze drying unit we used for drying the sediments. Before this, we tried to use oven in 50 degrees to dry our sediment samples, but soft sediments tend to solidify into harder stone, and it was really hard to work with those samples. So thankfully, we found the freeze drying unit for treating these samples. Next, a little bit about the treatment an analysis. So as a first phase, we did the drying, and then we went to with the density separation with the sediment microplastic isolation unit. And this is the unit that Rachel Koppock et al. Described first. And like the density fluid, add the sediment into the tube, and you let it settle for overnight usually. Then you close the valve, and then you can filter the top part of the tube into the filter. And on the two topmost pictures, you can see two sediment samples. And you can see that there's quite a difference between the sediment locations. So the one on the left has a lot of plant residue. It was quite horrific to see at the first time. And on the right side, you see a sediment which was more finer, sandy sediment. And because the sediment samples vary so greatly, we had to use some treatments to get the microplastics out. So we use enzymatic treatment with cellulose and chitinase. And after that, we added hydrogen peroxide to get rid of some of the organic material. And after that, we had a second density separation to get remaining sand dense. So that you can see on the right bottom picture. For the analysis, the samples were stained with Nile red in acetone, and I used about 2 milliliters per sample. I also tried other concentrations than 0.1 milligrams per milliliter, and other solvents like hexane. But according to my per milliliter test, this concentration and this solvent had the best fluorescent of microplastics and least fluorescent of background fluorescent. The photographs were taken with Leica fluorescent microscope, and altogether nine separated pictures per filter were taken and then stitched together with the computer software. And the analysis itself were done on Fiji software, which is open source and widely used in research world. And the script was loosely based on Ernie Cassola script, but I had to modify it quite a bit to work with my samples. And then I also, as a precaution, I took a selection of particles and analyzed those with the FDR just to see how much of the fluorescent particles were actually plastics. And then on to the results. Here is a picture of one of my filters, and you can see on the right side, you can see zoomed pictures of the smaller windows on the center. And you can see also, if you are really keen eyes, you can see that there's the outline made by the Fiji software. So you can get an idea how the analysis worked on these samples. A bit more about the results. This is the first main finding, I think. So the smallest size fraction, so from 25 to 50 micrometer, had significantly more microplast particles than the four biggest size fractions. And this should be taken into account when selecting the threshold you're aiming for, so the lower threshold. And especially when you're comparing between the results between studies, since the lower threshold usually equals to more plastics. And this is also important when you're selecting the filter you're gonna filter your samples into. And actually, 80% of the particles found were under 100 micrometer in diameter. And this has been described in other papers as well. For example, Have et al. Found out that 95% of the plastics they found in their study was under 100 micrometers in diameter. Yes. And the second main result was that there was a high spatial variation. On the map, you can see Pojo Bay, I described in the first slide, and the samples are located. The sample locations are marked with the yellow circle. City of Tammisaari is in the middle, which is marked with the gray color. And there is 2 rivers flowing into Pojo Bay from the north, and they flow in close to the sample location named Pohja, which is the northernmost part. And other aspect I want to mention is the deepest location, which is in Syvänne, where we also had a sample location kind of in the middle part of the Pojo Bay. And Tammisaari location, so the sample location closest to Tammisaari city, differed significantly from 4 other locations within Pojo Bay, marked with the star. And what I think is especially interesting is that even the second closest location, named Stadsfjärden, had rather low concentration of microplastics compared to Tammisaari, even though there was a bit more than 2 kilometers between those samples, and they're both rather close to the city of Tammisaari. And other locations with higher concentrations were Pohja, so the rivermouth station, and Syvänne, which was the deepest location. And even between Pohja, the rivermouth station, and the next station from it, so Sturön, there was quite a high variation in concentration between these 2 sample locations, even though they are somewhat 2 kilometers away from each other. I think it's very interesting. So there is a lot of variation in microplastic number within Pojo Bay. But there is also high variation between all the sample locations, so including the coastal stations. So in this graph on the vertical axis, you can see the particles, microplastic particles per kilogram of dry sediment. And on the horizontal axis, you can see the sample locations. On the left are the Pojo Bay samples you already saw on the last slide. But on the right side, there are the coastal stations, which I didn't show you before. And as you can see, there was a high variation even in coastal station as well. So what struck your eye probably is that the Porvoo has the highest concentration, almost 22,000 microplastics per kilogram of dry sediment. Sorry, but also that sample location close to Kotka and Vaasa had really low concentrations of microplastics. So, and to give you an idea how these compare to other studies, for example, Have et al. I mentioned before, they made a study in Norway, close to the city of Bergen, and they had 4 sample locations close to the wastewater treatment plants, and they found concentration varying from 12,000 to 200,000 particles per kilogram of dry sediment. So quite a high numbers compared to my 22,000 particles per kilogram. But then you have to remember that their threshold was lower. The lower threshold was 11 micrometers when I had 20 micrometers. So this might be one of the reasons why there was a high variation between the studies. And then we of course have some studies from the Baltic Sea as well. From the southern Baltic Sea, Esiokova et al. From 2020, they made a study where they had 53 sample locations, and they found concentration varying from 100 to 10,000 particles per kilogram of dry sediment. But yet again, here you have to remember that their threshold was a bit higher than mine. It was 200 micrometers, I think, or yes, I think 200 micrometers. So you cannot directly compare these results, but you get an idea of the concentrations in other studies. And as a summary, these were among the first sediment results from the Northern Baltic Sea. I had high microplastic concentrations. Number of microplastic varied greatly, even very small areas. But I think more samples is needed for holistic assessment. And that the smaller microplastics are more abundant than larger ones. And these results were useful for developing monitoring. And with that, I want to thank you for your attention.
Okay, thank you, Yuri. So do we have questions? We have time for one question. Okay.
Oh, thank you for your presentation. I see that microplastic concentrations in your study are quite high. So my question is, do you prepare some blank samples to control the external contamination? And if yes, then how do you treat them?
Yes, we had control samples. And yes, those controls have been taken out from the results. And then we also made the recovery samples to see how much of the plastics actually go through the for the sample process. So we had both controls and recovers.
Okay, thank you. Then thank you for the presentation, and we are going to our second one. The second is presented by Arun Mishra. Okay, are you ready? And it will be about the special temporal distribution of microplastics in the Gulf of Finland.
Kuvaatko muuten, että Viro onnistuu saamaan selvästi paremmin kuin Suomi tämmöisiä
Yeah, good morning everyone. I am Arun Mishra and I'm a second year PhD student at Caltech University. And today I will be speaking about the spatial and temporal distribution of microplastics, the Gulf of Finland. So these are my team members and my supervisors are Dr. Garmo Valley and Dr. Tabit Leblik. So this is our study area. So during the monitoring cruise from 2016 to 2020, we visited over 10 sampling stations. So then to better understand the Gulf of Finland region, we divided the Gulf of Finland into basically 3 different regions. As you can see in the sub-map, like there are 6 stations in the western part of the Gulf of Finland, 1 in the central and 3 in the eastern part. And the samples were collected only from the sea level surface, means only in the upper layer, and we used manta troll for our sample, and we had a mesh size of 330 microns. So these were the main results, what we got. And if you see year-wise, we have like all these concentrations which are given in the table, they are the mean concentrations. And you can see every year how the concentration changes. So what we see from this table is like mainly from the year 2016 to 2018, concentrations was generally more higher in comparison to 2019 and 2020. Now this is another explanation of the results. So these are our stations, and accordingly how microplastics varies between these stations. These are the details. But one of the very important point to note here is that not all stations were visited every year. The highlighted part in the green, they were visited only once in a year. So this is the important part here. Now we got, let's talk about the microplastic morphology. So here we only distinguish into 2 shape classes. One was MP fibers, which is microplastic fibers, and all other non-fiber parts. For instance, we found very small pieces of fragments, films, granules. That is why all other particles we categorize them as MP fragments. So we all know that microplastics are generally from 1 to 5 mm. But as we use the mesh size of 330 microns, so in our study we And the range of the microplastics, we kept it from 0.3 to 0.9 mm and from 1 to 5 mm. And from this figure, you can see the share of microplastics, fibers, and fragments. So if you see the yellow part is the fibers part and the blue part is the fragment parts. So we can easily understand, like in 2016 and 2020, the fibers content means the share was quite higher in comparison to other years. And what we found was that about 73% we got from 0.3 to 0.9 mm, and 27% was greater than 1 mm. Now we also found microplastics which had colors. So this is the overall figure which tells us what we found. And we can see that the most of the colors which we found was gray, white, and blue in color. But the fibers specifically what we got, they were generally gray and blue in color. And the fragments which we got was generally white and blue in color. Now that was the whole discussion about the results what we got. Now let's talk about how spatially it is distributed. So here in the six-figure panel, it tells what we did is like for each year we calculate the mean microplastics of that particular stations. So the first figure in the six-figure panel tells us the stations which were visited, and for each station the average was calculated. Similarly, it was done for all the other years. And the last figure in the six-figure panel is the arithmetic mean of all the sampling station which was here during the 5 years. So, and from the figure we can see like the microplastics was spatially distributed. And in the last few figures, I showed you like how in the year-wise the microplastic changed. So we can tell here like there was a significant difference in the temporal variation, and we did the ANOVA test to confirm that. Now we talked about the total microplastics, but now the question arises like which part of the Gulf of Finland region we have more microplastics. So here the Bose-Whisker plot tells us that we found more microplastics, the total microplastics in the Gulf of Finland West region in comparison to other two regions. Now we did the same spatial distribution, but this time it was for microplastic fibers, and the explanations remain the same, but here we calculated the mean for the MP fibers. Now the thing is like how it varies according like in 3 different regions. So what we found was that we found more fibers in the central part of the Gulf of Finland, which was station 14, which is the offshore station. We found more fibers there in comparison to the coastal stations, which is like Gulf of Finland West and Gulf of Finland East. Now again we did the same spatial distribution for MP fragments. Again the same explanation, so I will not go much into it. And now, unlike fibers, what we saw was that MP fragments was more in the coastal station than in the offshore station. And this we can see from the Bose-Whisker plot again. So until now, we have discussed about the spatial and temporal distribution, but we also thought to check if there is any seasonal change between the microplastics. So what we did is that our entire 5 years data, we bifurcated it into 4 different seasons. As you can see, we had spring, summer, autumn, and winter. So we found there were seasonal changes. And you can see like winter, there was only 1 sampling which was done in station 14. Now how this seasonal variation changes for different regions. So here what we are seeing is that we generally found more values, like the concentration was quite higher in the autumn and winter parts in comparison to spring parts. So here I would like to tell you one thing, like in total in 5 years in the Gulf of Finland region, we had total 78 samplings. Out of them, 50 sampling happened in the spring season. So that is the reason, in order to statistically say that there was seasonal difference, what we did, we only took into consideration summer, autumn, and winter to statistically say that yes, there is any seasonal difference. And that is what we did, and the ANOVA test to prove that. Now, until now, we have discussed about the spatial, temporal, and seasonal difference. But now, the question comes like why microplastic is higher at one station or why it is low at one station. Like what are the environmental factors driving it? Are there any, is it related to river discharge or is it related to something, the ocean process? So in order to do that, what we did is that first we tried to relate the microplastic with wind speed. And this wind speed data we took from the ERA 5. These are model outputs. And so for further analysis, we took 2 stations. One is station 14, which is the offshore station, and station N8, which is the coastal station, which is located near Narva. So from the left side, if you see station 14, The correlation between wind speed was quite ideal, meaning here like what with the increase of wind speed, generally the microplastic concentration decreases. Meaning that in the offshore area, what happens is like if there is more wind, then there is more vertical mixing. Meaning there will be low microplastic in the upper layer of the water. So that is what we found, and the R-square values was quite good enough to state like it is related. But now when we come to the coastal station, here what we are seeing is that like here the relation is not ideal. So here we cannot statistically say that microplastic is directly related to the wind speed. And if you see the R-square value, it is extremely less. So here, so the output from this figure is that the wind speed is related with the microplastics only for the offshore areas. So now we tried to correlate with the wind speed for station N8 and 14, but for N8 we could not found. So we went into more analysis. So what we did is that for station N8, what we did, like we had in total for 5 years, we had total 13 samplings in station N8. So what we did is that we took test cases now. So high concentration, we took 4 values from the top, and for low concentration, we took 4 concentration from below. And then we wanted to know, okay, why the concentration are high and why the concentrations are low. So these were the test cases. So now before jumping into this figure, I would like to tell you a few things here. Like what we are thinking is that, means our hypothesis is microplastic is coming from land to the sea. And how it is coming, basically it is coming through river discharge. So at station N8, we took Narva river discharge into consideration, and exactly on that sample date, we saw that the riverine discharge value was quite higher. So basically what happens is that the fresh water usually have low salinity, which everyone will agree. So what happens is, so our theory is that if the salinity is less, meaning the microplastics will be more. And when the salinity is, means the fresh water is spreaded means with the open sea water, that time the salinity will be more, meaning microplastics can get transported. So now let's jump onto this figure. So basically these are model outputs again, but this time we use the output from GetM model. So on the left hand side, as I told you, like we made our test cases. So these are +4 high cases which we took, and in the right side it was low concentration. So if you see the figure, yeah, if you see this figure, then you can see at this station, like the concentration here, means if you see the color bar also, it is quite easily understood, like here the freshwater influence is there, meaning it has not spread at that station, meaning the salinity was quite low. So here we understand that, okay, if the salinity was low, meaning microplastics gets basically trapped here in this case. And it is also very nicely visible in this case also, like it is quite blue, meaning it has less salinity. But high case, it is easy to understand. But in low case, what happens? So here if you see, the salinity content is quite high, meaning the fresh water which is coming, it has already mixed with the open water. So when it gets mixed, microplastic can get transported into any direction. It can get vertically distributed. So if you see this, then it is a very nice discharge which we can see in the model outputs. So here we understand that, okay, that is the reason we have low concentration at this place. So if you see the entire low concentration, the salinity level was quite high. And this is how we come to conclusion, like even the salinity is high, fresh water has already spread, and that is the reason we have low concentration. So this was all about the coastal stations. Now let's talk about the station 14, which was the offshore station. So here again, we saw like wind speed was directly related, but we also wanted to see what is the effect of salinity here. So again, we did the same thing. We took another test cases, but here we took another +4, means with the highest concentration, we took 4 cases, and for low concentration, we took 3 cases again, but 3 this time. So again, if you see the effect of salinity, if you see again the same theory of the fresh water, if you see here the high concentration part, the salinity was quite less, meaning the fresh water has not spreaded with the open sea, and that is the reason microplastics can potentially get trapped. And if you see all 4 figures, then it is easily understood the salinity concentration was extremely low for the high concentration case. But for the low concentration case, if you see the magnitude of salinity in both the figures, it is very high generally, meaning that microplastics can get get transported over here. So that is how we come to know, okay, we have low concentrations in here. But again, if you can ask me questions like here, salinity concentration is still low, but again, how can you tell? But what we did is that, particularly for this date, what we did is actually we checked the temperature plots. Yeah. We took the temperature plots and we also calculate the wind direction for, means as this was the sampling date, we checked for last 5 days and we saw the wind direction also. So from the wind direction we come to know like this is possibly an upwell linkage. That is the reason the salinity was low here. So this was the explanation, and in summary I would like to just reiterate what I said. So what we found was microplastic was present across all the sampling sites. The share of fibers and fragments were nearly the same. We found spatial and temporal distribution. And the main physical parameters which affects were the wind speed and its associated vertical mixing and the riverine discharge and its advection. So that's all from my side. And thank you for your attention. If you have any questions, I would like to answer them.
Time for one short question. We have one. Do we have questions? No? Thank you. Okay, then on the coffee break. So now we go to the next presentation. Philippe Leontiev will talk about the underwater landscapes in the eastern Gulf of Finland.
Thank you very much. So good morning, everyone. My name is Philip. I'm a part of SIGI Russian Geological Institute and also a participant of trilateral cooperation between Finland, Estonia and Russia called ER55 or Adrian Project. And before the presentation, I want to say thank you to the conference committee, especially for being here offline. It's a great opportunity to present our results and share some new ideas. So thank you very much. And moving to the presentation, today's topic is in search of relations between factors of underwater landscapes in the eastern Gulf of Finland using GIS and statistics. So briefly about the project, the aim of the Adrian project is to create a GIS portal where you can see the consequences of anthropogenic impact on the underwater landscapes ecosystem of the Gulf of Finland under various scenarios, including climate change. So doing monitoring and modeling on one hand, and also being in a cooperation with Finland and Estonia, we're searching for new ways to reduce the risks of human activity negative effects on biogeosynosis of the Gulf of Finland. On the slide you can see the example of a web page, of the project's web page. So here the set sheet depth is presented, and unfortunately yet the data of Russian site is not added, but we've got 1 more year to add our data, and after it in 2022 you can see the complex holistic picture of the parameters presented on the left. So we had 3 field seasons from 2019 to 2021, and I will talk about only 19 and 20 years because 21 year data is under the analysis now. So the spatial distribution of our points was based on, firstly, the multi-beam data when we had it. Secondly, it was based on lithological and thirdly, morphological aspects of the bottom. So we tried to highlight the main features of the Gulf and also to follow the idea of creating some kind of a net to have a complex map in the end. In 19 and 20 years, we did more than 300 stations, of which 200 was complex. By saying complex, I mean they were both biological data, geological data, physicochemical perimeters, and also we did the underwater videos on most of the stations. Here you can see some of the pictures from the fieldwork processes and the features of the Gulf. So on the left bottom you can see the example of iron manganese concretions, and on the right some kind of ripples on the bottom, and the lonely Saduria in the bottom right. After that, we did the laboratory analysis and some kind of preliminary data processing. So firstly, from the geological side, we did the grain size analysis for each station. After it, some preliminary result processing, and the most important and the final step of the laboratory analysis and data processing was the creation of database for modeling, which included first physicochemical parameters like Secchi depth, reduction potential, redox potential, hydrogen potential, and some other parameters, the type of bottom sediments, and of course the benthos parameters, including abundance and the biomass total and for each species. But why this topic of my presentation is important? So the desirable outcome of this work is the possibility of assessing and predicting the conditions of underwater landscapes using the relationship between biotic and abiotic components. So I think, yep, sorry, it's an old version of presentation, but okay. In some sense, the main outcome is some kind of bio, or on the other hand, geo indication. So if we know the correlation between parameters, we can assess, for example, geological factors using biology and vice versa. And for now, the relationship between the spatial distribution of certain types of bottom sediments and benthos at the level of mesohabitat was not revealed. So it was a part of our investigation. And as I said before, we had biological data, geological data, physicochemical parameters, but what is very important is to have geomorphological features of the Gulf, and especially on the points we had. So to do this, we used the BTM. It stands for Benthic Terrain Modeler, an extension for ArcGIS. And this extension allowed us to create such a model which highlighted the main features of the Gulf related to the geomorphology. So on the slide you can see the classification of mesorelief in the south part of the eastern Gulf of Finland, including crests, slopes, flat, and depression. And a few words, first steps towards the statistical analysis and the results of this, aim of our research. So, firstly, using our big database for more than 300 stations, we did a data preparation. So we exclude some extreme values using 3 sigma rule, and also we assigned ranks to categorical values, for example, for bottom sediment types. So 1 for ferromanganese concretions, 2 for gravel, so it's a big particles, and 10 for clay for future statistical analysis. But unfortunately, when we're trying to do an explanatory analysis looking at the graphs and plots, we had no evident relations. And in some case, it is obvious because our data is not, it is a natural data, and it is very hard to have the normal distributed data in that way. But we did pairwise Spearman correlation, and fortunately, we had strong relationships between total abundance of macrozoobenthos and surface water redox potential. So the coefficient, as you can see, is pretty high. And also, we had some connection between biomass of macrozoobenthos and oxic bottom condition. There is some moderate relationships, including salinity and benthos distribution. So it was said before, and it was discovered before us, that there is a relation between salinity and the distribution of benthos. But unfortunately, which was our aim of the research, we had a weak relationship between abundance and biomass, and on the other hand, sediments and mesorelief types. So our first steps was not so successful because we did not find any straight relationship between abiotic and biotic components in the underwater landscapes. But along with the Spearman correlation, we did simple linear regression, and we got the statistical significance in abundance and the type of sediments. So the p-value is pretty low, and it could say that there is a high potential for future investigations in this area. And also the multiple linear regression, which was done for abundance and the interruption of sediments and mesorelief types, also got us a nice result. So the p-value is pretty low too. Sorry, I had one more plot on the slide in the new version of presentation. We did the model assumption for the statistical significance of simple linear regression, and the QQ normal plot analysis showed us that this model is, it's fine, and vast majority of the points is straight on the line, so we should work on this model, but definitely we have some kind of connection between abiota and biotic components in the Gulf. And few words about our future plans and questions. We should add some more parameters in our model, including wave exposure, currents, and river runoffs. Maybe exact these parameters could influence our distributions, and maybe this is this could be a key role in modeling the connections between factors. Also, we had a 2021 field season, and we did more than 200 stations. Each of the stations was complex. So both biology, geology, physicochemical parameters, and we should run the model using this new data, but maybe better bathymetry resolution will be great for us for the Eastern Gulf of Finland, because now we have only 100 resolution data of bathymetry. And a small dream, it's detailed investigations. For example, it could be a Kurgalski reef. So here is the map for that kind of key area. Before that, I was talking about investigations on the mesorelief type, or on the mesorelief scale, sorry. But now it is very new to see and to look for the correlation on the small area. So very detailed investigations, and Kurgalski reef is a good key area. It could be a good area because firstly, we have a 3 meters resolution multi-beam data. Then we already have 9 stations of complex data. And thirdly, there is a high depth difference. So it could be very interesting to model it in the BTM. And we just need to make some new points on the slope, because it is very hard to get some samples from the slope, from the ship. So, but it could be very interesting to do. And the question is there any additional methods of GIS and non-parametric statistics which we can use to go forward in our not very easy, but I think very valuable investigations? Thank you for your attention. If you have any questions, please ask for them.
Thank you, Philip. And I think we have time for one question too. So do we have questions for Philip? So I think if you have any questions, we can discuss them further during the lunch. Thank you, Philip. And
thank you very much.
The last presentation is from Natalia Nasenko. Are you here? Ah, yes. So she'll present the methodological approaches to the establishment of regulations for the use of aquatorial zones of the Maritime Spatial Plan in the Russian Federation. So Natalia, the floor is yours.
Hi, I'm Natalie, and it's I feel very honored to be here and to present to you. And I'm going to talk about the methodology, essentially about the methodology of maritime spatial planning in Russia. So I will talk specifically about marine functional zoning, which, as I will explain later, makes part of maritime spatial planning. I will discuss main goals and functions and the principles of the use of marine areas, types of usage, and categories of functional areas of marine functional zoning. So the mechanisms for identifying water areas and establishing restrictions were developed by the study conducted by Irmak Northwest. And these mechanisms were formed on the basis of the existing legislation in Russia, which is essentially planning. It's the regulations for territorial planning and spatial zoning. These mechanisms take into account the changes dictated by the uniqueness of the environmental planning, specifically of the marine area, and target sustainable development, which also includes, of course, the preservation of the unique ecosystems of Russian seas. And as I earlier mentioned, the marine functional zoning system is part of the Maritime Spatial Plan, and it defines the rules of the use of marine space. Ultimately, it is the method of rational organization of space. So before I continue, I think it's important to outline the main goals and principles of the maritime policy in Russia. It aims to ensure sustainable economic and social development of the country. It aims to preserve and save the natural ecosystems of the seas and rationally use their resources. It takes a holistic approach to maritime activities and its differentiation in certain areas, taking into account changes in their priority, which depend on the geopolitical situation. And of course, ecosystem-based management, on which my colleagues have spoken yesterday. So marine policy in Russia considers the marine environment as a whole, and it takes all the processes within the ecosystems as part of the same thing. So functional zoning approach on its own, it's a part of marine spatial planning. It establishes the boundaries and functional purpose of aquatic areas in accordance with the preferred type of use. This approach allows to minimize or completely avoid conflicts between economic sectors, as well as reduce the negative impact on the environment. So it essentially minimizes the conflicts between stakeholders. And a marine functional zone is a marine area with certain boundaries, with a homogeneous functional purpose and corresponding modes of use. The functional purpose is understood as the predominant type of activity for which the space is intended. The goals of marine functional zoning are to protect marine ecosystems, as marine functional zoning should consider the marine environment and the natural landscape. So, for example, all the areas that are designated as nature protection sites should be strict and must strictly protect the environment. The next goal of the marine functional zoning is development of economic activities. So the development of the marine economy should not be achieved at the expense of the marine environment, which in other words is known to be blue growth. And it is essential to promote the harmonious development of marine resources and the development of the marine environment. And of course, the resolution of conflicts among industrial users, maritime and non-maritime users, and protection of the common borders of land and sea, which is essentially the coastline, because the coastline is a valuable marine resource on its own, and it must be strictly protected. The protection of the coastline also is an important part of the marine policy and the direction of the development of it. And of course, ensuring the security of national defense and taking into consideration the requirements of the military sector. And the functions of marine functional zoning are environmental protection, economic use, and reserved territories. So the principles for the use of marine areas are integrity of the ecosystem, rational use, and minimization of conflicts. So by maintaining the integrity of the ecosystem, we imply ensuring the safety of water areas, which are crucial for the preservation of biodiversity, ensuring the functional interconnection of zones, and perceiving the marine space as a single holistic ecosystem. By rational use, we mean providing sufficient space for existing economic activities while allocating space for new ones and future and potential ones. Promoting collaboration between different users where possible, and encouraging coexistence of complementary or interdependent users of the sea. Maximum saving of the sea space allotted to certain activities. That means that we aim to maintain the status of public water areas in as much space as possible to reserve it for future economic activities. So minimization of conflicts comes down to possibly combining use of space by types of economic activities with similar requirements for environmental conditions and infrastructure, determining priority type of use. Sometimes if there are several compatible users of the sea, priority is given to the already existing, the one that is fixed with the zone. Promoting collaboration between different economic activities. One example that I've recently been reading a lot about could be the restoration of oyster beds among offshore wind farming, but that's not in the Gulf of Finland. That's just an example of a collaboration between different economic activities. And encouraging the coexistence of complementary or interdependent users of the sea. So activities that we considered in the development of Marine Spatial Plan, they are environmental protection, first and foremost, sites of underwater cultural heritage, aquaculture, fisheries, renewable energy, including wind, wave and tidal energy, tourism and recreation, and scientific research, as well as marine transport routes and traffic flows, submarine cables and pipeline routes, marine subsoil use, which refers to oil and gas industry, military training areas, and dumping of soil. This is not an updated presentation for some reason, but landfills refers to, landfills is the wrong word here. We meant to say dumping of soil, as we're talking specifically about the storage of soil dug out in other economic activities. And other activities in the sea, such as artificial structures, islands, bridges, or anything else that did not get included in the previous categories. So the main function is the priority economic activity in the allocated area, and that's the most important term. And then there are three types of uses: permitted uses, conditional permitted uses, and prohibited use. They all refer to the gradation of strictness applied, restriction applied to certain zones. Permitted uses are the default activities that do not require any approval. Conditional permitted uses are activities that require approval, and if there's a conflict with another industry or another stakeholder which is identified as a permitted use, then the priority is given to the latter. And prohibited use, these refer to the activities that should not be performed in the allocated area. So categories of functional areas. There are nature protection sites or nature protection areas, areas with limited activities, and areas of active maritime use. So nature protection sites are effectively areas that are designated for the protection of the marine ecosystem, and they require minimization or preferably complete elimination of the impact of economic activities in the area, or sometimes the economic activity itself. So areas with limited activities are areas with a minimum anthropogenic load and restrictions on certain types of use, while areas of active maritime use are zones with moderate or significant anthropogenic pressure. The territories belonging to these zones suggest the location of zones with economic activity in them, and sometimes they have one lead function or can share several equally important functions. So nature protection areas, they are then subdivided into different types: protected zones, landscape protection zones, and underwater cultural heritage. Protected zones are patches of land and water that aim to protect, they have special environmental, scientific, cultural, aesthetic, and recreational value, or they have been withdrawn by the authorities fully or partially from economic use and have been granted special protection status. Landscape protection zones are aquatic areas where economic activities are prohibited or restricted in order to preserve the natural landscape. And underwater cultural heritage zones are protection sites which aim to protect, well, not the nature, but the underwater cultural heritage site underneath it. Yeah, so this is the nature protection areas currently in Russia. Sorry, not in Russia, in the eastern part of Gulf of Finland, with St. Petersburg to the right. Then we have areas with limited activities, which include buffer zones, sanitary protection zones, and restricted zones. And you can see them on this map. And then areas of active maritime use are, as I explained before, they are areas that include heavy anthropogenic impact in them. So merged all together, this comes into a comprehensive plan until 2030. And yeah. So in the future, it is assumed that there will be improved coordination between maritime and land planning, that there will be a better distribution of responsibilities related to maritime spatial planning and zoning, as we don't have a public authority established yet for the maritime spatial planning process. And we hope for a better resolution of conflicts between industry users, as well as increased attention to environmental monitoring and involvement of a larger number of stakeholders and their more active participation in marine functional zoning. And yeah, that's all from me.
Thank you, Natalie. Unfortunately, I think we don't have any more time for questions, and I would like to thank all of the 4 participants, our young scientists, for presenting their topics. We learned new things about microplastics. Distribution, we learned that there is a lot of microplastics in the bottom sediments. There is a lot of microplastics in the water in the Gulf of Finland, and its distribution is also can be related to natural factors, which is very important to take into account, not only anthropogenic. And also we learned some new approaches for finding relations between factors for underwater landscapes. And finally, we also learned about the methodological approaches to for functional zoning in the for maritime spatial planning for the Russian Federation. Hopefully, it will be implemented very soon for our maritime spatial plan in the Russian Federation. Thank you, and I'm closing this session and passing my microphone to Kai. Yes. Sorry. Then I will pass it to our organizers.
So I have not prepared any speech, and it's usually the best closing speech because it can be quite short. When we were planning this Gulf of Finland Science Days 1 year ago to take place in Tallinn, we were of course extremely disappointed that we had to cancel it and postpone it for 1 year. And this autumn has been really challenging for us. Some mornings when I woke up, I thought that it will be not organized in Tallinn, and some more mornings I was more positive. And when we came here on Sunday evening by ferry, then I realized that it will really happen. And then I got also message that the Russian delegation could come to Helsinki. Even some of them should have to do a new world record in running from St. Petersburg plane in Helsinki-Vantaa airport to the Tallinn plane, but everything was successful. And I especially want to thank Tarmo Soomere and Terje Tuisk and other people from the local organizing committee, and then of course Ludmila Vesikko, who did quite impressive work to bring the Russian participants here. So as a result of these days, I think that this was very high level event, a very interesting presentation, very good work has been done, and I think somehow that this Gulf of Finland Science Days have somehow found its position in this competition of very many conferences around the Baltic Sea and in our scientific community. So I hope that we will overcome someday this corona situation, and anyway we are hopeful that we could organize the Gulf of Finland Science Days in Helsinki in 1 year, and we hope that the situation with COVID-19 is then better than it's at present. So I wish you everybody a safe trip home and hope to see you in Helsinki in 1 year. Thank you very much.
I would like to thank, first of all the speakers and also the technical staff of the Academy and the technical staff who have organized this very nice connection to those who are participating remotely. So seeing the face on the screen of those who are participating remotely, it makes them to be almost with us. So when I was trying to summarize what we have actually learned here, maybe not so much, but still, I think we have updated and made much more detailed some of the existing knowledge, which is always very highly appreciated. I would like to specifically thank plenary speakers for their contribution. They all, in a way, widened our horizons, showing that actually no disaster is looming, except those what we can organize ourselves. Some changes, what many believe to be extremely complicated and hazardous, they actually only exist in minds of people. But they are the most dangerous. But there is still a lot of room for improvement, for better input, and for better input not so much into policy, but for those who have the mandate and obligation to make different decisions. They are called policymakers. And those who are shaping the policy, those who are advising our governments, parliaments, policymakers. It's really good that the number of case studies is increasing, but it's increasing in the frame of different joint projects. And the scope of those projects is also widening. Technically, of course, we know for decades that marine environment is almost never homogeneous. And vice versa, it's actually extremely patchy and highly variable both in space and time, and that very interesting phenomena may take place in the small Gulf of Finland. But what we start to learn, I think within last decade we had this turn of minds. We are learning that marine space is also, as such, is also not homogeneous. It doesn't mean only, say, marine protected areas or spawning areas or specifically vulnerable areas. The entire Baltic Sea is highly vulnerable area in terms of international maritime organization. I think the change is that the sea is becoming more and more our home, our common home. And we share our home between different functions. We normally do not sleep in kitchen, and we do not play football in the living room. So we have different areas for different functions. And this is what we do now with the sea in terms of maritime spatial planning. And this is a place where our experience, our knowledge, and our ability to foresee the future, at least to some extent, is very much needed and would be, of course, very much appreciated. From scientific point of view, this exercise is like a variation of a global optimization problem. And in this context, I would like to remind that we have other global optimization problems underway in part of the countries who are participating here. I have in mind here the Green Deal of the European Commission. Not as such, but as I mentioned, as a as an example of a global optimization problem. So the point of Green Deal is fivefold. There are 5 targets which must be all achieved together, and no drawback in any of the goals is accepted. And the goals are basically very simple. First, it's carbon neutral society in terms of emission of greenhouse gases. Second, economy must be increasing. Third, nature must be preserved and well kept. Fourth, both health and wealth of people must be increased, so we must live better, must live happy lives without infections if possible. And fifth, nobody is left behind. It is extremely complicated to achieve all those targets in one move. So when you have a system of different connections, like Markus Meyer was demonstrating to us how complicated the impact chains are, if you move one lever, then some other may move into an adverse direction, and this is not accepted. So it is a global optimization problem to move in all 5 directions positively all the time. So maritime spatial planning is pretty much a task of similar kind, at least conceptually. So we have to make best out of this part of our home, not damaging its functioning and helping it to recover from the impacts in the past. And at the same time, we have to solve almost infinite number of competing and conflicting interests. So it's a nice school of democracy to make such exercises. But one thing which came out on this conference, I think for the first time in the history of Gulf of Finland marine science, is the possible thinking that even the sea may have its own rights. It might be treated as a fellow citizen, not a domesticated pet. And this metaphor of domesticated pet is really important. You have probably all read Antoine de Saint-Exupéry's The Small Prince. And the fox is telling the small prince, if you domesticate, you take responsibility. You are responsible if you have domesticated somebody. So this is much more than just protecting some areas or zoning the sea according to the best use. It's about rethinking of the entire attitude, which is called in standard ways out-of-the-box thinking. And thinking that the nature has been a very good ally for mankind. So let's act so that it will stay as an ally and never turn into an enemy. With that, I'm happy to once more thank everybody and to say that the conference is technically closed, and now the doors into the future will be opened behind me. And you know what is expecting you in the future, so forecasting this future is as simple as that. Thank you very much.